Okay, here we are now with the sixth question of 1A from Linear Algebra done right. So we basically wanted to show the associativity of complex multiplication property, where wherever you put the brackets, it doesn't matter if you've got three complex numbers multiplied with each other. So first, we need to define multiplication in the complex numbers, and we're going to use the definition from the textbook. I didn't memorize this, I just expanded and worked it out. And we're going to reference that as 1 because I don't want to write define multiplication in C every single time I use it. Then we'll begin by letting alpha be this complex number, a plus bi, do the same for beta and lambda. So now we can use these to manipulate them algebraically and hopefully show that the left-hand side does indeed equal the right-hand side. Okay, so the first step, actually I'll leave that up there so you can still read it. The first step is in a problem like this where it's pretty complicated and you're going to get lost even if it's fairly simple, is to work backwards. So we know that our result that we want is alpha times bracket beta plus beta times lambda. So we go alpha by itself as this complex number times in brackets beta times lambda. That's the end result we want. And then we can expand it using our definition of multiplication in the complex numbers, and we get this slightly horrendous thing. Then we expand that again, so now we've got blue in blue here, one complex number times another complex number, so we can use 1 again. So multiplication in the complex numbers, we can use this definition again, expand it, and we get this beauty. So I spent about 5 minutes trying to figure out why this wasn't equaling what I got down to in my proof. It was because I missed a plus sign in the second bit here. I said AC minus BD plus AD minus BC. It's plus, don't forget that, those kind of little things. But the general idea was correct, so hopefully in exam I would have gotten only lost a couple marks. Okay, so once I got to this point, I was thinking, okay, if I expand this, I get ACE ADF minus BCF minus BDE, and that is looking like what happens when you go through the proof and begin to expand the left-hand side as a complex number. So I expand the left-hand side, do exactly what I did up here, just with the left-hand side now. So I expand that, and we get this. And then if I expand this out further, multiplying, distributing across, I get this, which kind of looks simpler because it has less brackets. And I noticed that if you expand this, if you distribute this out, it equals this. And so all we have to do is now work backwards from here to this result, working backwards to the right hand side. So using 2, that's not 1 right there, that's a 2. So I'm using 2. We know that that equals that, and then we just reverse the steps from our working backwards. So now it's working forwards to get to our end result. So we just reverse these steps, and we get alpha times beta times lambda, and beta times lambda are in brackets, which is the right hand side. So this was fairly easy conceptually, but the algebra is a mouthful. And doing these techniques, like working backwards at the start, is probably going to help you organize your thinking. And so that is question 6. I will see you in the next one.